Hi guys, welcome to this new video where I want to speak how to create a polycurve. This one, as you can see here, is a polycurve, but it's called oval. This oval is composed by different arc of circle. Here there is one arc. Here there is another arc, and then I mirror this curve in this side, and then these two curves in the other side. Here you can see a grasshopper definition, useful to make it changeable. I can change the radius of this part of the polycurve by moving the slider. Oh, sorry, this is a part of the polycurve, and I can change the major axis and minor axis. So this is the major axis, and this is the minor axis. How can I do it? It is important to know some information. As you can see here, there are three variables. The first one is the radius of this arc, of this part of the polycurve. This is the variable, and this one is the slider. And another variable is the major axis. This is the major axis, and the last one is the minor axis. Starting from these three variables, it's possible to create a polycurve using knowing any information. You have to remember that it's possible. If I have this arc, I can connect the end of the arc with the end of the minor axis, and I can connect these 2 points with this line that will intersect the arc in another point, this one. So I find the direction of this line that will intersect this other axis in this point. As you can see, this triangle is similar to this triangle. This line is equal to this line. This line is equal to this line. This angle is equal to this angle. This angle is equal to this angle, and this angle is these two angles of these two lines and these two lines are coincident. In this way, is it possible to, with this information, is it possible to create the oval using just 1, 2, and 3 information? Okay, let's start. So, File, New Document, and the first thing that I have to do is put a point inside the digital space of Rhino. But this point is, first of all, I have to put this point inside the canvas. So in params I can find point, and I can put it here. With this component, with this parameter, I can connect one point inside Rhino with Grasshopper, but if I click with the right, I can set one point and put it inside Rhino space, digital space. I want to use a grid snap and put it here. Okay, You know that it's possible to select the point, the parameter inside the canvas, and here there is a sort of gamble that allow me to change the coordinates of the point. Here I can see what I saved, so I can change, oh sorry, not here, I can change the coordinate of the point. Perfect. So I set one point in a specific place here. Okay. Well, now this is the center of my oval. If I want to create first of all I have to create the major axis, and I can create it by using a line. So I can go here in curve, and I can use line SDL. This is line SDL. Line SDL, in input we want the start of the line, the direction of the line, and the length of the line. The start of the line is the point, could be the point, because first of all I have to create the half of the major axis. Okay, so I can start from the center. The direction could be X direction, and here I can put the dimension of the axis with a slider. From 0.001, no, sorry, 001 to 20 could be my the dimension of my major axis, that I have to divide in two parts with divide. Division. Okay, and I can put a panel equal to 2. Perfect. And here I will obtain the dimension of the semi diameter, the semi axis, half of the axis, and I can put it here. So this is the whole axis, this is the half of the axis, but I can start from the center. This is my aim. Okay, so one. But I have to extend this curve in the other side with the same length. Here in curve you can find the extend curve. The curve that I want to extend is this, and here I have to decide the type of extension. 0 is it means line, and here I have to decide the side of the extension, from the start or from the end, or both. The end is this one, the start is this one. So in the side of the start I have to extend this curve with the same dimension that is here, and in the other side I can put 0. So I will obtain my axis starting from the center. The same things I have to do in the other side. So I can copy this but I have to change the direction of the line, so I can cancel this and I can put Y. Here I can put Y. Now I have this is the center of my drawing. This is the center. This is the division, could be the same panel for both. Okay. This is my center, and here I have the minor axis and the major axis. So right click and major axis and minor axis. Okay. Minor axis is shorter than the major axis. Okay. We can work now on this, or more could be good. Okay. Now I have to create this circle. I draw this line. Now I have to draw this arc, and this arc, for this arc I have to decide the radius. I can extract the start of this line, and I can move this point along this direction with the dimension of the radius. Okay, so endpoints. I'm interested in the start, and from I have to move the start point along this direction. So move what? The start point along this direction. Sorry, not this. My fault. Is this? This is okay. Sorry, it's not correct. Now it's correct. And the direction is this, but with a number that is this. So with amplitude, take a vector and change the module, the amplitude of this vector. This one is a unit vector, but with this component that is here in vector amplitude, I can change the module. It maintains the direction, but change the module. That is this. This is the module. And I can put this vector inside move. Sorry, I have to decide. No, it's not this. I have to decide the amplitude that will be the radius of my circle at the start. So I can take this. I can change the name of this slider with radius. radius, okay. I can put the radius here and I can change it. Okay, perfect. Maybe I want to, it's okay. It's okay. And this is the center of the circle that will have this dimension as a radius. So in curve I can find arc, arc, arc. Arc, the input of this component are the base plane of the arc. The base plane of the arc is the word xy, xy, the word xy with the center in G. Okay. And the radius is this number. But I don't want the whole arc, but I want a portion of this arc. This arc has a domain. There is a domain. This arc start from 0 and it ends at P. In radians, this angle is called P. P, that is 180 degrees. But I have to change the domain of this angle. I'm not interested in this domain, but my domain will be from P, the alpha of the P, and P. So set domain from P to P divided 2. Perfect. This is my arc. Now, as I said at the start, I have to create. Now I have this arc, this line, and this line. I want to connect these two lines from this point to this point, and I want to extend this line and intersect the curve. So I want to know the start of this arc. It's easy. Endpoints. I need of the start, and I want to connect with the end of this axis. So endpoints again, and I can create a line from the end to the start. Line from, oh sorry, not this, line, 2 points, from the end to the start. Oh, not this. Why? Okay, it's so. Okay, perfect. So now I have to intersect these two curves. it's easy because in intersect I can find a mathematical intersection called curve line. This one is the curve, this one is the line, and I will obtain this intersection that is the point, the intersection point between the extension of this line, because this component considers this line an infinite line, and in this way it can intersect this line with this curve. Well, now I have to create an arc that connects this point to this point. I have to remember that an arc, if I want a tangent arc to this point, I have to know the tangent in this point of the curve. I can do it with evaluate curve. I can do it with evaluate curve because with this I know this parameter. Here I can see the parameter at the start. Okay. At the start, I want to check some things. Sorry. Here, from P to OK. Here I know the parameter at the start and the parameter at the end. And with these two parameters, I can know this, the tangent in both the points. In both points, I can display the vector point, and you can see the tangent in this point and the tangent in this point. But I need of this. I need this point and this tangent to create a tangent arc. Okay. So this is the first intersection. This is the second intersection. So with list item, list item, I can take not the first but the second element. Not the first is 0, the second is 1. And I can put this in this, and I will obtain what? I take it. The list. I need the list. Oh, sorry. Sorry. This is the list. Perfect. This is the vector, but it's not this, because in the list the first is the other one. So the 0 item. Perfect. Perfect. Now, is it possible to create an arc? Because I know the start of the arc, the end of the arc, and the direction at the start of the arc. In fact, here there is arc SED, start and direction. So the start is this point, the start is this point, the end is this point, and the direction is this direction. As you can see, I've created this curve from this point to this point, tangent with this direction. Now I have to trim. I have to split this curve in this point. In Grasshopper it's impossible to split, but I can create a subcurve. A subcurve is a part of the curve that starts from this point with its domain and end to this point. I know the domain of the start, but now I want to know the domain at the end. The domain at the end is the start of this curve, but here I can read the parameter in the digital space, but I want to translate this parameter in just one number that is the parameter of that point on the curve. So with this component, I can project a point on a curve and obtain the parameter of that point on the curve. So the point is this, the curve is this, the parameter will be this. It's the opposite. Okay. Oh, the start is this. Sorry. Oh, perfect. This is correct. This is correct. Yes. Yes, this is correct. Perfect. So, this is the start of my curve. And this is the end of my curve. The end of my curve. So I can create a new domain from this point to this, from this number to this number. Domain. Domain. Construct domain is the correct parameter. Okay, from this point, and I put T in A because T is the start of domain, and this one is the end, this one, because I need T of domain. And now I can create a subcurve. Subcurve that is a portion of the arc. So I can take the arc, and here I can find the portion. There we go. That is the portion of the arc. Now I can hide this. I can hide the line, not this one, but this one. And this one is a perfect tangent arc with this arc. Okay, I can hide this. Now I just to connect with join these two curves. So this curve with this curve join. Not this, sorry. Join curves. Okay, I can flatten the input at the entrance, this one and this one, to obtain okay, so I can obtain this curve. Now I can mirror this curve with this plane, the plane YZ plane, YZ. So YZ. And the center of the plane is this point. So I can connect this with this. And I can create a mirror curve. Mirror, mirror, mirror. I can mirror this with this plane. It's perfect. It's perfect. And now I have to join. We have to join this with this and mirror again, but using the XZ plane. XZ plane. So Control copy and paste, and that is the center. I have to connect the plane with the center. I have to remember. Sorry. Okay, this is the final curve, is the joint curve. So join curves. Okay, and this is the perfect oval. So this is the result of my definition, and now I have these three parameters. So I can change the size of my oval. But there is here there is a continuity of tangent, a tangent continuity, G1. Rhino called this kind of continuity G1, and I can change I want to hide these two. I can change the major axis. And change the major axis, and I can change the minor axis, and at the end I can bake to obtain this oval, this perfect oval.